as we have just described the relationship between torque and moment of inertia, similarly on the same grounds, we have the axis of rotation and a rigid body, the constituent particles at various distances of separation from the axis of rotation, right? So right now we are talking about angular momentum. What is angular momentum? It is the product of linear momentum with distance. First of all, let's talk about what is linear momentum. Product of mass and velocity of the particle, and angular velocity is linear momentum into the perpendicular distance of any particle. From where? From the axis of rotation. Basically, angular momentum is moment of linear momentum. Like moment of force was torque, moment of linear momentum is angular momentum. That means the physical quantity would be multiplied by a perpendicular distance. Now, instead of P, I can write mv, and instead of v, if this body is given an angular velocity of omega, v can be written as r omega times r. So this becomes m r square omega, right? This is the value of angular momentum. So total angular momentum of the whole body, whole rigid body, will be of all the particles which are at their respective positions or respective distance from the axis of rotation, right? So total angular momentum of complete body would be individual angular momentums of individual particles, which would be m1 r1 square omega plus m2 r2 square omega plus so on mn rn square omega. If I take omega common out from this, I'll get L equals to m1 r1 square plus m2 r2 square plus mn rn square times omega. What is this? This is the moment of inertia, so this becomes I omega. This is L. So this is the relation we are looking for, L equal to I omega, or in terms of vector it will be I omega. This is the required relationship between angular momentum and moment of inertia.